This lecture is being brought to you in part by the generous gifts of these sponsors.
First, a gracious and sincere thank you to Dr. Ford and everybody here at IHMC for the wonderful invitation to come share some of the work that we've been doing over the last nearly 10 years at Nauticus. And it's been quite a ride, and I can't wait to tell you all about it. So I did spend 14 years at the Johnson Space Center, very formative years, got to work with some of the best and brightest that anyone could hope to start a career with. I got to work in the robotics group, leading a lot of flagship efforts when I was nearing the end of my tenure at NASA. And towards the end, 2014, I decided I wanted to take a cup of Starbucks coffee and be able to walk through the threshold of an office building and say, this is my company and I'm starting it and I can't wait to grow it. Wow, what I didn't know was going to happen, and it was very difficult. So recently, sorry, I got some stuff on the computer. Recently, we went public last year on the NASDAQ under the ticker symbol KITT, K-I-T-T. I was a huge fan of Knight Riders, and I was like, if you can't have fun with your stock ticker symbol, you're taking yourself too seriously. And so I couldn't believe that KITT wasn't taken, and so we took it. So our main software program that runs all of our robots is called Toolkit. And so, we just changed the spelling, added a T, and there you go. So what I'm going to speak with you today, and I'm very honored to be here, is this concept of having spent a bunch of time in space and all the developments that we did in the robotics community and how that has applied to the world's oceans and marine environment. So I have a first question. Let's get some interaction started. It'll start easy. Who were the first two people to land on the moon? And Buzz Aldrin. Where did they land? Sea of Tranquility. Here we go. I like this. What did they land in? What was the name of it? Lunar module named the Eagle. The Eagle has landed. Wow, you guys are a very astute crowd. Okay, so 9 years earlier in the there was another first to the world accomplishment. The first two people to go to the deepest part of the ocean. Who were they? Wow. It's gonna prove my point before I even get done with the lecture. All right, here we go. It was not the brother of the guitarist or the drummer from the Eagles. It was not Joe Walsh. It was Lieutenant Don Walsh and a Swiss oceanographic person named Jacques Piccard. 1960. Yeah, Jacques Piccard. So the first two people to go to the deepest depths of the Earth, about 11,000 feet under the water. What was the ship called? You guys are already... Where? Trieste. There we go. Beautiful name for the place in Italy where it was built. And where did they go? In the Mariana Trench. It was named for the similar of the Sea of Tranquility. It had its name. What was it called? Challenger Deep. Very good. Okay, awesome. So we got a C- on the ocean part and an A+ on space. So that is going to lead me into a lot of what we talk about later. So I'm a roboticist. I deal in robotics, and I want to take you through a little bit of my journey at NASA, starting first motivating it by a couple ideas. We're in this new robotics revolution, and about every 5 years somebody says we're in a new robotics revolution, but no, really this time we're probably in a new robotics revolution, and it's not the rise, but it is the adoption of service robots. So contrast that with industrial robots that really dominated the first 50 years. The first industrial robot, Unimate from Universal Automation, installed in a General Motors assembly plant in Cherry Hills, New Jersey, 1960 something or other. And ever since then, as the kids would say these days, it went viral. And we did a bunch of stuff with manufacturing with industrial robots. But ever since, the last 10, 15 years, we've contemplated the concept of that maybe robots can get out among us to do stuff. So we've been really hard at it. I don't know if FedEx is going to get here anytime soon. They just shut down their delivery robot system, so we're probably a little far away from from the FedEx delivery robot that I just showed you. And it seems to be a theme because Amazon just shut down their delivery robot, and we tried making pizzas with a mobile robot factory, and they were unable to do it. $445 million raised for a pizza startup that could not keep the cheese on the crust. Look it up. That is true. So $500 million later, we have no idea how to keep cheese on crust. Mobile, right? The little thing it was being delivered in. So this concept that maybe we can build robots that can help us do stuff for us, right? We're good at painting, we're good at welding, we're good at pick and place, good at making circuit boards with robots, but yet to have robots in the world actually helping us. There's a lot of research being done here at IHMC. You can just go to the lab and you can see that the researchers here, the world-class research being done here, are really focused on how can we create the platforms that are going to get out into the world and help us do stuff. And right now, we want Sunny from iRobot, and there's a lot of researchers here working on Sunny from iRobot, but right now we have Roomba from iRobot. And there's a big difference between Sunny and Roomba, but we're going to close it. Now, I was fortunate enough to work at NASA, and we actually had a market for a humanoid robot. It's a very, very bespoke market. There's only really a market for one. We flew a robot to the International Space Station really to work on cleaning the space station, but we progressed to get there. So early on, NASA started dabbling in humanoids. 1965, they built this thing called Android, not too different than Petman from Boston Dynamics early in the day. This was built to exercise a spacesuit. So when we were learning how to build spacesuits, we didn't want people in them. We want to put robots in them to make sure that they work right and they could stand the pressure or the vacuum, etc. So then along the way, we came up with this concept in 1996 called Robonaut. And the next 15 years of my life would be dedicated to building this robot. So that was back when we had little PowerPoints, and you put them on little projectors, and they put them on the wall, and we had little graphics like that. But in 1998, we created this robot called DART as we were progressing towards this concept of a robotic astronaut. 2000, this is when I got to the lab. So I get to Johnson Space Center, and I'm walking through the halls, and I'm actually working in mission control at the time, very young, just out of college. And I was not in the engineering group. I was not in working as a roboticist. I was working as a flight controller on the robotics on the space shuttle, the SRMS. And I was walking by this facility. I got lost. NASA's a huge campus. And I'm walking down this hallway, and I just look into this room, and I broke my neck snapping back, and on the wall was this robot. And I go, what in the is that? And it was the most incredible thing I'd ever seen. And I was like, who's working on this? Who's building this? Why are they building it? And I'm going to figure out a way to get into this lab. And when I retired from the agency in 2014, I was running this lab. So 2001, we put 2 arms on it. 1 arm's not good enough. 2 arms, pretty good. And the thing I would never suggest anybody ever do is put it on a Segway. It was very dangerous. Broke a lot of stuff. That was back when we were learning about Segways. They were exceptionally dangerous pieces of machinery before we figured them out. And so we kept going. So, okay, 2 wheels, screw it, let's do 4 wheels. And so now we have this concept, we're going to put it on another planet, remote geologist. So this idea that you could step inside the robot and immersed in teleoperation and control the actions of the robot in this way where you're wearing VR gear and you're seeing what the robot sees, and we're going to put it on another planet. And we always put space probes before we put people, and this is a good logical idea. So then we said, okay, throw out the first version. Let's do another version, right? We're engineers. We need to build another version. And so let's build the second version, Robonaut 2. And this time we developed a relationship with industry, and we said, General Motors, NASA's broke. We need some cash. We need you to come in and help. And so they came in and helped fund, because General Motors knows a lot about robotics. They're actually the world's largest buyer of robots every year. Painting, welding, all the assembly for a car. And they said, well, what if we can put that robotic technology in general assembly? Let's say, what if we can have a robot put a window mirror on or put a dashboard in? There's a lot of repetitive injuries that occur. The Auto Workers Union are very aware of the injuries that occur with all these repetitive tasks. Let's make a robot do it. So GM was very interested. So we're like, all right, well, let's put some big wheels on it. So we made even bigger wheels. If we're going to Mars, we're going to Mars with some big wheels. And then we're like, okay, let's launch it to the space station. So we started building more of one. We had two now. So we put one on a space shuttle, launched it up. And then we're like, all right, well, you don't need wheels in space. You need legs in space. But these legs aren't the legs that you would think about. They were very kind of freaky. Look at this thing inside the space station. Why did we put it in the space station? Because we built a Roomba. So this is a big, fancy Roomba. It would clean the space station. So every Saturday morning, the astronauts spend a lot of their day cleaning the space station. There's a lot of bacteria, microbial growth, etc. We need to make sure it's clean. But we want the astronauts doing exploration. We want them doing science. So we built the world's most expensive Rosie, the robot cleaner Roomba. This is one of the things I'm most proud of. This was sort of my last thing that I did at NASA, and it is actually in the other building, as Ken said. Excuse me, I'm recovering from RSV 3 weeks ago. I'm about dead. So let's make them walk, and let's put some legs on them. It's pretty cool. So we built a couple versions of Valkyrie. I had left NASA in 2013, but this is the latest version of Valkyrie 2016. So I want you to take a look at this video because this is really the concept I want you to have in your head when I start talking about ocean stuff, and I promise I'll get there. So take a pair of manipulators into the world and have it do stuff, right? So this is called mobile manipulation. It was not a fancy term, but it was a term coined by some researchers that said, we want to be able to travel around and do stuff. So this robot was told, pick up a rock. And there's a lot of things that have to go on in the robot's mind in order to pick up a rock. So this is being done about 15 years ago. So you can imagine everything going on in the computer architecture, the autonomy, hardware, pick up a rock. So we did fly that robot to the space station. And if you can humor me, I will give you a little story on that before we get into the ocean. So we took the upper body, because that's all we could afford to fly at the time, and we packed it into a box. It's a very complicated procedure, putting it into a box. There's a lot of screws, a lot of screwdrivers. It's very complicated. And we had to train the astronauts on how to do this. And the astronauts are a fickle bunch. Every second of their day is scripted. They're told when to go to the bathroom. They're told when to sleep. They're told when to eat. And as a consequence, they go through these little periods of micro-mutiny. You know, you're not my dad. You can't tell me what to do. And so we fly this robot to the space station with a very complicated procedure on how to unbox the robot. So during one of the loss of signal events, wave goodbye. So during one of the loss of signal events, the astronauts actually unpacked the robot. It was over a 90-second period of time. This was a 45-minute procedure, and in 90 seconds, they unpacked the robot and then packed back an empty box. And then went through the 45-minute procedure with the ground. I was on the ground. I was in mission control, and we unpacked an empty box, and I went, where's the robot? And I look over to my colleague, and I was like, I thought you put the robot in the box. And he's like, I thought you put the robot in the box. I'm like, which box did you fly? And Katie Coleman and Paulo, they kept it up for a while, and then they showed us that they'd unpacked the robot within 90 seconds and then proceeded to go through the 45-minute unpack the robot box procedure. And then we had the first robot astronaut handshake in space, and then Saturday Night Live, of course, picked it up. So that was pretty cool. You know, something that you're working on ends up on Saturday Night Live, and you start questioning, am I done? Am I done in my career? I've done it all. And we got a call from the president as well at the time, Obama, and he was like, this is pretty cool. All right, yeah, it's pretty cool. So I got an epiphany because we got a lot of tours in the lab, and those tours would say, wow, this is fantastic technology. Have you ever thought about putting it underwater? And the first time you hear it, I'm like, Second time you hear it, you're like, all right, tell me more about it. Third time you hear it, okay, like this is interesting. And so, how do they do stuff underwater? All right, if you want to do something underwater, you have to take out a really big boat, and you need to drop off a refrigerator dishwasher looking thing connected to the world's largest extension cord, 2 or 3 miles of cable, just so that you can deploy these hydraulic manipulators. It's run from a room full of people. There's one guy flying one arm, there's another person flying the other arm, there's another person flying the body. They're talking about what they had for breakfast. It's $6 a second. It's very, very expensive, and it's very simple. The tasks that they do, they use squares, and they use circles and triangles, and they insert tools, and they rotate stuff. And I thought, I bet we can automate that. I bet that we can come up with an architecture where we can cut the umbilical If you can cut the umbilical, then you can completely change the cost structure. You can use a smaller boat. You can use no people. You can use a robot that doesn't need to be controlled by anybody in real time. It can be, told to do stuff, because that's what we did in space. So here's the connection. Told you I'd get there. So when you put a robot on the moon, it's not connected there by an umbilical. And what's the time delay to the moon? The time delay to the space station is 3 seconds. By the time it goes over to White Sands from Johnson, it goes up to Tidris, it bounces around a little bit, goes in the space station, comes out, goes into a router to computer, goes to the robot. 3 seconds later, the robot does what you told it to do. Underwater, same exact thing. You're talking the speed of sound through water is 1,500 meters per second. And that's the only way we can communicate is with sound, acoustic modems. So we've come up with a way to do networking underwater with acoustic modems. So that's how we communicate with robots. But you cannot control that robot with an acoustic modem. You have to use an umbilical, fiber optics. Because there's a person, as you saw on the top side, using a joystick and controller to move this, to do every second, to control that robot every second. There's no autonomy in that machine. There's another kind of robot that just swims around and takes pictures. I just gave you the entire taxonomy of robots underwater. They're boxes and they're torpedoes. They do stuff or they take pictures. Now, the ones that take pictures don't have umbilicals, right? Because they swim really far. But they don't do anything other than take pictures. They just swim to a point, they turn left, they swim to a point. It's like a NASCAR driver. They swim to a point, and they take pictures. So, why would we even care? What's the big deal? Excuse me. Well, the ocean is probably the epicenter of every part of your life. Amen. It is undersung. It is not spoken about. It is 95% of all life on planet Earth is in the ocean. And it's funny to even call it planet Earth. We live on planet Earth. It's stupidly called Earth, but it's an ocean planet, right? So if you took the economic value of terra firma, where we're sitting, and you took the economic value of the oceans, it's 20-1 in favor of the oceans. Yet, what do you think NOAA's ocean exploration budget is? It's laughable. $30 million a year. Not only is NOAA's overall budget only about $6.9 billion, 5 times less than NASA's, their ocean exploration budget is about 1,600 times less than NASA's. It's insane. And here's what's beautiful about it. So the data that you're getting on your phones, when you're going home watching Netflix, 99% of all data transferred around the world goes through telecommunications cables laid in the ocean, not through satellites, through telecommunication cables. The food that you eat comes from the ocean. The clothes that you're wearing were shipped across the ocean. The minerals that we will require for the energy transition will come out of the ocean. There's more rare earth material and minerals on the bottom of the seabed than all 7 continents combined. That's how valuable they are. There's $20 trillion worth of installed infrastructure in the ocean. 70% of the economy of the ocean is hydrocarbons and energy. It's a big deal. There's also some negative things. If we keep overfishing the oceans at the same rate we are today, within 40 years we'll deplete the usable stores of fish. So sustainable aquaculture and sustainable fishing is starting to become a burgeoning business. It's a big deal. And let's talk about pharmaceuticals, which I didn't even know. Pharmaceuticals. Ocean is the largest supply of potential drugs. Millions of chemicals have come out of the ocean that go into drugs that help us every day. Not only that, it absorbs about 30% of the CO2 emissions that are released in the atmosphere. So it's the largest carbon sink. Another thing. Here's what fascinated me about the ocean. There are cities underwater. I had no idea. Cities underwater that need constant maintenance, constant repair. And that ship that I showed you the first part of the talk is $6 a second. So if I need to go underwater and turn a valve, it's $100,000 a day to have 60 people deployed offshore just to turn a valve underwater. And you don't really appreciate the scale. Some of these structures are the size of stadiums, right? This is not small stuff. These fields are kilometers by kilometers by kilometers big. And the thing that I really found fascinating as well is, let's say we're going to build some offshore renewable wind farms. It doesn't make sense to put a offshore service vessel spewing out 70 metric tons of CO2 per day in a renewable wind farm. So I was like, oh, that doesn't make sense either. So maybe there's another way. So I decided about 10 years ago, I said, what if we take all the technology that we built at NASA with mobile manipulation and we combine it with some of these AUVs, autonomous underwater vehicles, that don't have any umbilical but can only take pictures? What if we combine space flight with some of the latest tech in the ocean? These are common, right? This was 20 years of research to figure out how to get a robot to pick something up on its own. I can read about how to build that in a book. So let's smash the two together. And we started a company. So we had to solve this challenge. We're like, all right, well, if we're going to make a torpedo that's pretty hydrodynamically efficient, and refrigerators are not, and that's kind of what the other side of the equation is. So we got to create something that's able to change forms, because if we're going to swim really far without an umbilical and then do something, we're going to have to change forms. So we came up with this concept called aquanaut. It starts out as a torpedo, hydrodynamically slender shape, but then the same vehicle turns into a robot, able to do things at a distance underwater. And and so as a marriage between space and ocean, this was like one of the first times we ever tested the robot. This is NASA's Neutral Buoyancy Lab. It's the world's largest, well, it used to be. It's a large indoor swimming pool. It's about 8 million gallons. And so we were playing around with the robot for the first time. We're joysticking around. The only reason it has an umbilical on it is because NASA thought it would run away and smash into their mock-up of the space station. And I assured them that it wouldn't, but they didn't care. So we had to have an umbilical on it. But if you watch here, it changes forms from a robot that can swim around like a torpedo to a hoverable platform, able to scan, look around, using all the same concepts of the attitude control of an ROV, and also has all the sensing of an AUV, those robots that can swim around and take pictures. And the coolest thing is it can deploy a set of arms. This is literally the first video we ever took when we put it all together. And so you'll see the head pop up here in a second. It's got cameras, it's got lasers, it's got structured light, it's got really fancy ways to view the underwater world. And the big crescendo is it can deploy a pair of manipulators, just like I showed you on those robots before, and it's able to affect change in the environment. So it is a real-life underwater transformer, which starts as a submarine and turns into a humanoid robot. And then the engineers were like, oh, it works. Let's do it dance. Let's make it dance. I was like, we just booted it up. Calm down. But they put it back together. And then, it folds back up and then turns itself back into a submarine, and it can swim to its next job. So that was the thesis, right? This is 2016, 2017 time frame. So we're like, all right, well, batteries suck, so we're going to have to transport it somewhere. So we went and bought a boat from the Miami Police Department. We had to vacuum out all the white stuff from the couches. And then so we decided to outfit the boat with technology so the boat could drive itself. And so now we have Aquanaut, which is our transformable submersible that can do work underwater. And then we put it on the back of a boat that is able to drive around. We have a crew here, but our new boats are optionally crewed. They're completely autonomous. And so we put the two of those together. And this was our pre-production prototypes. We were proving concepts at this point. We're like, all right, can we build a robot that can swim and do stuff underwater and take pictures, take the survey data? We did a lot of work in the intercoastal waterways and the Galveston Bay, and so then the Navy and other people in the government knock on the door and they're like, hey, this is interesting. And I'm like, I know this is interesting. And so we started working for a lot of other objectives. So some of the IHMC engineers in here, that is loud. So some of the IHMC engineers in here might remember the DARPA Robotics Challenge. We literally took the DRC and put it underwater, using all the same concepts, all the same kind of visualizations, real-time simulations, And that's exactly what we did. So then we made it super, super, super smart. And so we absolutely pushed the envelope on autonomy. So we told the robot, find the connector and plug it in. So we then grabbed a cup of coffee and we watched. So the robot was able to locate the connector, realized that the robot understood that it was not picking it up from some end it could use, so it had to switch hands. So it then says, "Oh, I got a connector to plug in." And it's like, well, in order to plug it in, I'm going to have to use the other end of this thing. So then it analyzes what it has. It then says, "Okay, well, let's figure out where this thing goes." So then it elevates itself, tries to figure out where it can go, and then realizes it needs to create a reaction force on the surface, and grabs one side of a task board and then plugs it in, simulating doing an extensive repair or doing an extensive activity underwater. No one told this robot what to do. We gave it a task: pick up the connector, plug it in. So this is some of the latest and greatest concepts in machine learning and artificial intelligence that are being demonstrated underwater. Now, here's what's hard about underwater stuff. It's not like all the machine learning concepts today. If I was going to build an algorithm to not hit a cat in a self-driving car, I could scour the internet for millions of contextually labeled images of cats. Here's Fluffy crossing the road, chasing the ball. And then these training algorithms can digest this and come up with a beautiful neural, fuzzy, fractal, chaotic, genetic, atomic algorithm to avoid hitting cats. Underwater, we don't have any of that data. There's not millions of images of underwater stuff that we can train on. So we have to come up with new concepts to train on the fly, train in situ, meta-learning, zero-shot learning that is done online so that these actions can be learned and deployed in real time. It's some of the most advanced machine learning going on underwater right now with our company. Now, the first version was okay, but it has problems, and we're engineers. Let's build version 2. So version 2, it's nothing $100 million won't solve, and I'm not joking. It's about $100 million. So we said, all right, let's make it a little better, a little slenderer. And we came up with version 2. This is called the Mark II, Aquanaut Mark II. And we came up with a better boat. We came up with a better launch and recovery technique. This shows you, so now we have a boat that is absolutely autonomous. We're building these boats in London, just south of London, at a shipyard. We control them onshore. We have remote control centers. And so we have an optionally crewed vessel that deploys a subsea underwater robot that can do all the work of the big, gigantic boats. So that big boat I showed you at the beginning of the presentation, that thing's like 200 feet long. It's like a cruise ship. You should put Disney characters on it, right? This is a boat you could ski behind. So there's a hugely different cost structure. We communicate it with an acoustic modem. We've got a 101 kilowatt hour battery, the size of a battery in the Model S. And it has all the latest gear, electronics, and 2 electric work class manipulators, so that when it gets to where it's going, it can deploy them and do all the work underwater without an umbilical using spaceflight technologies, 100%. So I believe this robotic navy that we're building will completely change the offshore industry. That is the mission that this company's on. And it is, this is 21st century technology. Instead of using ROVs that were invented in the 60s. And if I showed you the most advanced remotely operated vehicle, that big refrigerator, dishwasher looking thing at the beginning, if I showed you the most advanced and the first one ever made, you couldn't tell me which one was which. So we started a manufacturing facility. We do all of our manufacturing in Vancouver, Canada. We've built 3 of these machines. We designed the entire thing from the ground up. Our staff is brilliant. We started building more of one. We started deploying them. We actually did an exercise with the Navy. We did some exercise in last week. We were in Rhode Island. We do all the commissionings. It's pretty awesome. And this is called Pantone 172C. It's lava orange. And I said, hey, listen, if we're going to build advanced robots, I want it to be like a sports car. This thing is going to be awesome. So I was walking through the mall one day and I saw a Porsche GT3 RS and I said, that is beautiful. I looked up the color code and we painted those robots exactly that color. And they are much more expensive than a Porsche. So it's totally cool. Really, this is probably and undoubtedly the most advanced undersea robot that has ever been built, that I believe is going to change the way that business is done underwater. This is our first production hydronaut built from the ground up. That's getting the launch and recovery system that I showed you in that animation, and being built in the United Kingdom. So what's the big deal? What is the difference? So to highlight this point, that boat is what we're competing against. It's $100,000 a day with 60 people on board to run that boat, because it has to store 3 or 4 miles of extension cord to run that very archaic robot. We said we can do the same exact work with a little boat and a really smart robot. Our cost to run that offshore is about $5,000 a day. We charge 40 grand a day, which means it's a good business. You should buy some stock. All right, so I want to end the talk because I know we're getting a little on time, and I'd love to hear from you. I'd love to hear some questions and make this a little bit more interactive. So I'm pretty passionate about this subject, and there's no worse critic on a smoker than an ex-smoker. So I'm a rehabilitating space junkie, but I've learned that the relevance of our world's oceans. Listen, I love the space folks, right? I love the throttle jockeys. I love the astronauts. I love all that, right? And more power to them. Let's go explore. But we got some issues here too. Maybe we should look at that. Maybe we should be investing the technologies here and exploring some of the greatest unknowns, right? Both space exploration and ocean exploration, right? Incredible risks, unfathomable problems that have to be solved, incredible discoveries, right? 5% of the ocean is mapped on any level. That's fascinating to me. 5%. Isn't that intriguing to the new generation coming up? Wouldn't that be awesome to go discover the new things that are in there? 5% of the ocean is mapped. 10% of it has been explored on any level at all. Yet 95% of all life is aquatic. So I think we have our spaceships pointed in the wrong direction. So with that, I'll end, and we'll take some questions.
Thank you. Can you speak about the interest of the Navy in your company and what their goals would be with your product?
Just think like James Bond type stuff. Yeah, we have relationships and contracts with folks in that area.
About 13 years ago, we had an oil spill off the shore.
Deepwater Horizon.
Deepwater Horizon, exactly. Would your technology at this point, would that have helped in the recovery and the turning off of the spigot, so to speak?
So this is going to be publicly released, and so I will not comment on any of that. However, what I would say is that I feel that technologies like what we are creating wouldn't have hurt. So response time is a big deal. I believe that when you scale out this concept and you create these Ubers that you can call up. Let's say I'm on an oil platform and I have an iPad and I call up an aquanaut, and it says inbound 22 minutes. And the little autonomous boat comes over and drops this thing off, and you give it instructions on what to do. I can't believe that that's a bad idea. So I believe in this networked robotic navy where if you get it at scale, it's going to completely change our concept of working offshore.
You talked about things under the water we don't recognize, things like that. AI apparently can help in that. Where's your embracing of AI and using that for algorithms for recognizing things we don't understand?
Yep, so that's exactly what we do. So about 60% of the workforce that I employ are data scientists, software engineers. So it's the largest discipline that we have at Nauticus. A lot of the hardware components, you know, trust me, I'm a hardware engineer. The avionics, the composites, all of that's wonderful, right? But it's what's between the robot's ears, which is really important, right? The degree of self-directed and self-sufficient behaviors that these robots can illustrate. That's the long-term scalability of this, right? Putting them out there, giving them abstract missions, go turn this, go pick that up, come back, right? So the more we can reduce and abstract that away and reduce the workload on a human operator, and they're just typing in missions for it, right? So all of that is artificial intelligence. Now, there's not Chat GPT running on the robot, although we're thinking about it. Yes, sir. I'm not the person calling. I didn't realize there was a mic over there. I feel terrible. Sorry.
So my question is very related to what you just said, and it's, what are the tasks that you can do totally autonomously? Because there is a lot of sequential decision making in the video that you showed us with plugging something. So I was wondering if you can name 3 tasks that you can do.
So when you put metal in the ocean, it starts to corrode. And so there's about $10 trillion worth of stuff installed in the ocean, and we have to monitor it. And there's a lot of physical monitoring that happens. So you take a probe and you place it on these particular spots on objects, and you measure the cathodic protection that's left, right? So when something's in salt water, it starts eroding away. It's a way to think about it. So we have to measure the rate of that erosion. The only way to do it is to physically interact with it. And until today, the only way to physically interact with something was with an ROV vessel. So that is one of the first topics that we're going after. Secondly, cleaning. There's a lot of gauges down there that need to be read optically. So you take a cleaning brush and you clean. There's a lot of valves that have to be turned in a quarter way. So you have a torque tool, you insert it in a valve and you turn it. So this is what I got excited about. It's not hard. I'm poking stuff, I'm inserting tools, rotating, and I'm like, that can be automated, right? I'm not talking about welding. I'm talking about very simplistic tasks that are perfectly posed for automation.
When skilled human beings do things, they very often practice multiple times mentally beforehand. Is that part of your AI that's going on here? So that I noticed there wasn't any hesitation going on. Is it like simulating it beforehand it moves?
Yeah. Well, there's a lot of simulation that's done, and then there's a lot of a priori offline training. So yes, we go on data gathering expeditions. We go off and we collect a ton of data, multispectral data, sonar, structured light with lasers and cameras. And we collect all that data and we take it up from all these different angles and all these different lighting conditions, and then we train the algorithms on this is what a valve looks like in 70,000 different angles and 70,000 different lighting conditions, and we seed that into the robot. And so the robot is more robust when it starts doing stuff underwater.
Does it do that in real time while it's working?
Well, it's doing the classification in real time. The training is done a priori. Now, we are looking at learning techniques that are online, as I was mentioning, because there's so little data available to do the training. And data gathering is super expensive. So for the early stuff, we went out and gathered the data. We said this is what marine growth looks like. This is what these objects look like underwater when they've been submerged for 2 years. The more extensible side of this, the training will be done online. But we're not doing that yet.
Welcome to Pensacola.
It's a pleasure to be
We're
here.
in love with the Gulf of Mexico. We are so blessed. When I was 30, I had a 85 female mentor who had a little statue on her mantle, and it said, "Salute the ocean, your mother." Is there any chance of you mining some unknown spot on the ocean floor just to look for unknown elements, just new things that we've never known before?
Like I said, there's a large portion of the ocean that is unobserved, right, unexplored. So if you look at seafloor minerals, there's a couple of different mining companies that are looking at it. There's a lot of environmental issues, regulations. You don't want a big, gigantic Hoover vacuum cleaner down there screwing up all the ecology. So these manganese nodules that are scattered on the seafloor, are in ultra deep water, I'm talking 6,000 meters of water. That's kind of our best bet right now, and they're little nodules about this big. So going around collecting them, putting in a basket, or collecting them in an efficient way. There's companies like the Metals Company, I believe, or Deep Green. I think they changed their name, one or the other. So they're looking at things like that. So seafloor mining is a big deal. Recently off the coast of Japan, they discovered a near infinite supply. That was the headline, near infinite supply of rare earth metals. We just can't get them. So yet, correct, exactly. So are we going to find other elements? I have no idea. It's not my area, but I bet we'll find some interesting things. Excuse me.
Yes. What is your confidence level protecting usage for military purposes, as in the Navy or other, that it won't get hacked and weaponized against us? And in a correlated thought, and what are our favorite competitors in China up to?
Next question.
So got one investor question, one engineering question.
Yes, sir.
So the investor question is, how much of your current customers government related, kind of like a Palantir, can't talk about it type fashion,
Yeah.
and how much is more private, oil and gas and things of the sort? And the second engineering question would be, is there going to be an open API toolkit that allows you to use the kind of like spatial awareness system that you're putting in these bots, put it in different type of robotics, kind of like the way Tesla's doing,
Sure.
the Tesla into the Optimus and so on?
Yep. So the first question, right now our revenue is dominated with national security interests. About 70% of our revenue is aligned with that, although that's changing because the reason we don't have as much commercial revenue as we'd like is we just went through pre-production to production. So we just got done with our production of our first run. And all those units coming off the assembly are already under contract with Shell, Equinor, Petrobras, big energy companies. We just won a grant from the United Kingdom to qualify for offshore renewable services. So we're definitely picking up commercially. But as it stands today, 70% of our revenue is defense oriented. Yes, I very much want to be able to expose the software in an open source way to help seed other researchers and help bring awareness to the kind of robotics that needs to happen in the marine community. However, the really fancy stuff you're going to have to license. Got to make some money. Going back to your investor question.
So how deep have you been, or how deep can you go?
They're rated for 3,000 meters. And so we know that. Almost 2 miles underwater. That has been verified.
Have you repaired cables underwater? Can it do that in the telecom industry?
No.
And one other question about biofouling. Are you
Yep.
having issues with that, and do you have any solutions? And you could talk offline.
Yeah, so biofouling, so ship husbandry, biofouling is a huge deal for ship hulls. There's 3% of global emissions are from shipping, and a significant portion of those global emissions are from the extra drag of the surface of the ship that gets all the different, biofouling material on it. So I know companies that work in that area, some very, very excellent companies. What we're concerned with biofouling is as our systems corrode, or as our systems, we use protective materials, coatings, etc. But it's not the highest concern. Now, the structures we're going to are typically biofouled, and that's why we have cleaning brushes where we have to clean the biofoul off so we can read the gauges. Excuse me.
A question in regards to your dollars spent and dollars received. Can you say, not including the military, of course, is how many dollars are generated here in the U.S. versus how many dollars we take and spend overseas on products that we've developed here in this country? Are we safeguarding these systems that we're developing in the United States, or do we sell the product and the outside to European countries to spend the money with?
So we have two versions of this system. I didn't show you the defense version. defense version is not painted bright orange. It's more battleship gray, and it's ITARD, international trade regulated. It's got sensors on it that we can't export, and it's for our purposes. The version that you see here is exportable. We don't sell the unit. We own and operate it. We sell the service. So this is a RAS model, a robotics as a service. So we own, operate the device. Because the device brings a compelling advantage, we can sell the service at a premium when our costs are very low. So that's the commercial opportunity for the company. Now, the Defense Department does buy systems because the people performing the service are usually wearing camouflage. So we're not that service provider. But the systems that get sold to DoD, we don't know what they do with them.
So what is the next technological paradigm you think in this space that you're going to be moving towards in the future? Like you mentioned how, like, ROVs hasn't, updated their technology since the 60s. You created something that, expands on that. What do you think is the next step after this?
For the company or just the community in general?
Company and the community in general.
I would like to connect better with the retail crowd. I would like to connect better with the consumer side. I would like to get into the human element of this. Human exploration, human-rated submersibles, I think that would be phenomenal. If sea levels are rising at the rate at which they are purported to be, maybe the solution is not shipping humanity to Mars. Maybe it's creating coastlines that are invariant. Maybe that's hotels. Why don't we have a partnership with Hilton where we're talking about building the world's first bimodal hotel, which is half of it's underwater, half of it's not, right? So I think there are far-reaching concepts that are going to head in that direction. But as far as the company's going, I would really like to connect a bit more to the consumer. And I don't know if that's buying a pool cleaning robot company. It worked out well for iRobot. But I can't get over this idea of exploring. So exploring. How do we bring the oceans to everyone? Even though 75% of the world's population lives within 50 kilometers of the coastline, we still don't think about it every day, right? You look up, oh my God, space, it's romantic, let's go flying. And most of the world's population lives pretty close to the ocean, right? But you never think about it. I bet you guys do. Usually I'm giving this talk in Colorado. in a smoky room.
On that note, let's thank our speaker.